All right, lesson 5, modeling higher degree polynomials. So the goal of the day is to be able to produce a higher degree polynomial that models a real world situation and make predictions with it. All right, so we've modeled so far in this class linear. That's what we started. We did some linear modeling, and then we did some quadratics modeling, and now we're going to look at higher degree. And Desmos can model anyone, and it's not any really harder how many degrees it has for us to plug it into Desmos. So let's go to some examples. All right, so worldwide internet use in millions. So model using a cubic function. Use the cubic model to predict number of users in 2010. All right, so I see the table goes to 2007. I want to know what will the number be in 2010. And so what we're going to do is we're going to plug all these things into Desmos. All right, so we're going to put the numbers, put that table into Desmos. And then once you put the data into it, I, of course, like to find my data. And there's two ways. You can zoom out and kind of find it, but the X values are way too spread out here, so it looks like it's a straight line. So the other way to do it is to plug in kind of what you think the window should be. And I look at the X values. 1995 is my smallest X value, so I'll go a little bit smaller than 1995. We'll put 1990 in there. And then it gets up to 2007. So we'll do 2010. And then we go to the Y values. It gets as low as 16. I'll just put 0 there. And then it gets up to 1,215. I'll go 50, 2050. Okay, so there's my data. And if you look at the data, it looks, kind of, we're doing cubic. It told us to do cubic, but it looks like it's kind of cubic because it looks like it's getting steeper. It's curving, and then it's not going to keep curving higher and higher. It looks like it's starting to flatten out a little bit. So we'll type in for it to create a cubic model. So we haven't done that before, but all we have to do is start now with, we start with the Y1, of course. Once I start typing Y1, squiggly or tilde, and now I start with an x1 cubed, right? Because this is a cubic. It's asking me to do a cubic model. bx1 squared plus c x1 plus d. Now, since I'm doing cubic, then I got to put a 1 for everyone below it, right? And if you look at this model, pause it here. If you look at this model, it looks very good, right? This blue line follows my points pretty well. And if you look here at the r squared value, it's 0.9966, right? And 1 is like a perfect model, like the data is perfectly on the line. And so 0.9966, that's very good. These points are very close to this line. And before I get too far typing here, use the model to predict the number of users in 2010. So here it's giving me the year 2010, and it wants me to come up with the number of users. Well, if you look at my table, years are what? Years are the X values, right? So they're giving me an X value, and they want me to find the number of users, the Y value, right? So since they give me an X value, I want it to be X equals, right? They're giving me an X value. So X equals 2010. And there is the 2010 line, so I can click that point. And so when it's X is 2010, what's the number of users? The number of users is 1,420, if I round, 24, because you can't really have 0.5 of a user, right? 1,424 users in 2010. So we put in some data, we constructed a model, and then we use that model to make a prediction. Let's do one more example. All right, model using a quartic function. So that's degree 4, okay? Use the quartic model to predict the number of unemployed in 1999. Here they give me the year, and then the rate, the unemployment rate. And so again, we're going to plug, and it's telling me to use a quartic model. So it could be like I just don't tell you the type of function, and maybe you need to look at the data and determine, does it look linear, like a straight line? Does it look quadratic? Does it look cubic? Does it look quartic, right? But I'm going to always give you which degree to use. All right, so again, I'm just fixing my x values, and my y's. I kind of made a mistake here. So I looked up here and said, oh, the smallest is 3.97. So I put a 3. Then I went down here and said, oh, the biggest is 6.8, which isn't true, right? Because the biggest numbers, there's 9s up here, right? So some of them are off. And I looked at that, like, oh, there. Okay, so I zoomed out a little bit. But look at that. That does look quartic, right? Up, down, right? Boom. So let's model this with a quartic model. And I'm doing this a little bit quicker, but I'm going to slow it down towards the end. So you start with a x1 to the 4th, and you got to do the 3rd, then you do squared. But the problem is the next letter. I'm going to hit pause here. Pause. I put a D here, and then so my last letter, you'd normally say, oh, the next letter would be E. Technically, you can put any letters in these spots, A, B, C, D. We've just always been doing it in alphabetical order. The problem is E has a value. E is see this right here? There's an E right there, right? If you look at a calculator, E is a button on your calculator. So if you put an E here, Desmos does not think you're thinking it's a letter E. It's thinking you're thinking it's a number. So don't use E. So I skipped E and I used F. If you put an E here, it'll give you a really weird looking graph. All right, so it's modeled, and if I look at my r squared, 0.76, which isn't spectacular, right? And if you look at this, this is the best quartic function that can follow these dots, and it's not doing a super job. It's not bad, not doing a super job though, but it's the best we can do. And so now it wants me to make a prediction of the unemployed in 1999. The unemployed in 1999. All right, so, and again, it's giving me a year, which is an x value. So I'm going to plug the 1999 in for an x and see what the y is. So x equals, I want the x to equal 1999. Whenever I'm ready to start typing, there we go. And then I got to scroll, and so in 1999, the rate was 2.754, right? So the rate, unemployment rate, is 2.754, predicted in 1999. So we entered the data, we created a model of whatever degree it's telling you to use, quartic function, and then you're using that model to make a prediction. So that's what the problems are going to look like today. What is the degree of the polynomial? Now, we haven't looked at this one that's like this before. That's why I put this in here, because this has two variables, right? So remember, the degree was always the highest exponent in a term, in the terms of a polynomial. Where's the highest degree? And here's a 3, but this has a 2 and a 2, right? So which one's bigger? Well, the degree of this term, if it has multiple variables, right, you add the exponent. So this is actually degree 4 is what this is. And again, you wouldn't know that. We haven't talked about it until right now, but I wanted you to understand that. So we've been doing it with a single letter, with a exponent, but if there's multiple letters and multiple exponents in one term, you add the exponent. So this is degree 4.